People that are artistically inclined or have a good design sensibility kind of feel like magicians to me. I've always been not that. And people then take that and pair it with electronics and really bring that expertise into the electronics realm and kind of show it to people like me. It's even doubly so. And Sarah Petkus is one of these people. She has been taking her ideas. She started in the illustration realm, and she still does a lot of that and really makes these great conceptual art that then she turns into real electronics things. And we're going to talk about that here. And I've followed Sarah for a long time. I met her at Maker Fairs and got to meet her through that, and we kept in touch through other conferences. And one of my favorite things about this episode coming up is that it kind of felt like we were just standing in a hallway at a conference and talking through projects again. And that's something in the year of COVID 2020, when this is being filmed, that is something I missed. And so getting to talk to Sarah like that has been wonderful. Now, a bit of the terrible part of this is that me, Chris, the doofus, I lost the video element. And so I feel so terrible about this, but I could not turn down putting out this content. So what we're gonna do is I'm gonna be going through, and we won't have any video content from the actual video when we were sharing this stuff, but I'm going to actually be sharing Sarah's work, which of course speaks for itself, and I will be sharing that during the YouTube part of this, right? As you probably know, Contextual Electronics Podcast is both video and audio, so people listening, nothing's different. People watching, it's a little different, and so what I'm going to do is basically go through and share her work as we're talking about it, because we were doing that actually as we were talking live as well. I feel really terrible that I lost this video, and Sarah was so gracious about it, and but we're still figuring out the whole video element of podcasting as well, and so we're going to move forward with this, and I'm still going to show you all of her work. Regardless, you should go to her site and check out Zoness.com. Has all of her work on it. She does these great animations on the site as well, showcasing her work. It is so cool, it's so interactive, and I really enjoy talking to her about this. So, all you video people out there, you're gonna see me kind of manipulating the screen and showing that. All you audio people, you're all good. And here we go with Sarah Petkus, one of my favorite makers, artists, and electronics people out there. I really enjoy talking to her, and I hope you enjoy it too. All right, so we're here with Sarah Petkus, and we're going to be talking about robots and art and electronics and lots of other things. Welcome, Sarah. How you doing?
I'm doing great. Thanks for having me on.
Yeah. So you have tagged yourself as Robot Mama in the little video thing here,
Yes.
and that's what I think I first saw your drawings about it, and then I saw Noodle, who's the robot we'll talk about here. But how did you get started into the robotics art field? Like, how did you start doing all this stuff?
So I guess in the beginning, I was an illustrator. So I went to a more traditional art school, like back in the day. And I drew comics and stories and things like that. And for college, I did a lot of printmaking. And I luckily went to this great contemporary art school that had a lot of different departments. And one of them was an art tech department where they had classes like robotics, electronics, and fabrication for motion, and just making moving things. And my printmaking professor looked at the content in my work and saw that I liked to draw like schematics, like as a motif in my designs, and more mechanical things and robotic characters. And they're like, why don't you just make the things that you draw? Which for some reason had never really crossed my mind. I think the entry level into engineering seemed a lot higher back then, because 3D printers were just about to come out, at least for the consumer ones, the desktop ones.
Yeah.
So it always seemed like way above my head to get into engineering. And once it was suggested, and I took a couple like classes, I think I only took maybe a year worth of classes there. That was it. My life veered in a different direction. Yeah.
That's really great. Yeah. And I mean, do you have any of the comics to show real quick, or is it mostly pictures? You've prepared some pictures of boards, which I very much appreciate. Or where could people find maybe the pictures of some of the early comics and things like that?
Actually, a really good example of just everything that I do is my website. Like for me is zoness.com, ZONESS.com. And if you go there, it's hand drawn. And whenever I add something that I've created to my site, I actually just draw it and then add it to the archive. But on the site is just basically me. And if you mouse over all the different things on that page, it animates and just sort of gives you a vibe of, there you go.
Yeah. Yeah, this is really great. This is in. So how often are then? So I mean, these are all your different projects as well, like you
Yes.
mentioned. How often do you go and update this then?
I think every like year or 2 years I'll change it
This is
because
great.
I don't look like that anymore. So I think I'm about to update it again. But it is pretty much the same format. It's me sitting in the environment that I work in with the current projects I'm actually doing in life on the table, and then whatever I look like now. So I got to update it for the quarantine bun and the long hair.
Yeah, right. And actually, the late play, the dancing robot army.
Yes.
I remember actually that I think is how we first met. I think it was at a maker fair.
Yeah,
yeah. Well, so what was that one then? So that was like a Delta robot, or how is that different?
Oh man, let's see. One of the first things, the ambitious things that I ever decided I wanted to do as I guess a roboticist was create like a field of flowers that you could control with your mind or your body, which was this.
I mean, naturally.
I mean, that's what you want to do when you grow up, right? Is have a robot army of flowers. I conceived of this because it was something I used to draw. Like I think Osh Park, they have like an illustration of a character floating over a field of light bulbs, and they're like swaying or whatnot. And I was like, well, I'm going to make that one of these days in some capacity. And back then, I wanted to create a robot that could move very agilely and could be small and reproduced like kind of on the cheap, right?
Mm-hmm.
And that was right around the time that MakerBot came out with the replicator. And I decided at that point that I wanted to make a 3D, like mostly 3D printable robot that I could just crank out and then build the field with. And I decided on the Delta robot because it is agile and it is pretty simple. Like you can get a lot of,
and it looks awesome too. I mean, like the Delta motion is just like so cool, and the math there is really cool.
Yes, it was exciting to, I don't know, like design the robot as a whole, because it went through a lot of iteration to get it so that you could just kind of pop them together, because building each and every one of those took like a significant amount of time. So I was trying to optimize for like, I guess, expediency, so I could just amass my army quickly and then take it to Maker Faire. And every year it got bigger and bigger. But yeah, like the deal with that installation is that you could walk up to the collective or the field or the army, and you could control them with your physical gestures. Oh, thank you. Perfect.
Sorry, I meant to have us both on there. Sorry about that. I'm still learning all this stuff. Yeah, so we'll have some movement in the background. Yeah.
Awesome. Yes, that is them. They are they're all pretty much 3D printed except for the motors, of course. The acrylic bases that they're attached to are modular, so we can actually stack those pods up in like a pile and throw them in a U-Haul and take them with us. Oh, they're living in one of our guest bedrooms right now, so we actually have a room filled with just robots.
That's got to be trippy to always be like, oh yeah, Sarah, where do you keep the toothpaste?
Yes.
And what's in my room?
Yes. I mean, anytime we have a guest, we always show them the robot room, because it's the sad thing about this is that after exhibiting them for like 3 or 4 years, they start decaying and falling apart.
Yeah.
So
wear and tear.
Yes, and there's a bunch of like injured robots, floppy robots in the back room, which is sad. But it takes money to kind of keep them going, and unfortunately, like a lot of the places we exhibit them, they don't pay an artist fee. Like Maker Faire doesn't necessarily do that. So we need to do another Kickstarter to get them back in working condition. So for now, it's just I go in there and I visit them. They all have names. Yes.
Oh, really? Okay.
While we were making them, we were actually like I would finish one, and then Mark and I would decide on a name for it. Oh, look, it's young me. Oh, my hair's short. But yeah.
And you're sinking into the field of for the people listening, we are watching the YouTube video that's on Sarah's site, so you can go and view all this stuff. So Mark's there
That
as
that was
well. Yeah.
actually a tent. That dome that they're on, like we could climb
Mm-hmm.
into it, and that was the command center.
Oh,
So we
like a geodesic tent kind of setup.
yes. So
Cool.
people didn't know this, but if you saw that at Maker Faire, we were actually inside of it drinking beer. True story.
That's the way to do it. Yeah.
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 But Mark
Yeah.
designed the. I designed the original circuit board for these. They're like it's a little
Mm-hmm.
hexagon. Um, let's see. Yeah, it came loaded with the code that ran the Delta robot. But after I did the first version of it, Mark then took it and made it like a big kid board because my partner and collaborator Mark is a professional electronics engineer. He does that for a living, and he the boards he makes are like the kind that you find in actual like computers and stuff. So after
Got it. So maybe a little more bulletproof, but no less functional. I mean, it seems
yes,
like yeah,
he did a real good job on those. The
that's
networking
great.
and all of that he conceived of. So the part that got those things to do what they did, that was his
Mm-hmm.
realm, and he did.
Yeah. So when you were building that first board, I mean, how are they all talking to each other? How are they all controlled on board?
I believe he controlled those with through DMX. So there, which
Cool.
is like a stage lighting protocol. So they're
Mm-hmm.
serially connected, but then they talk to each other through DMX, and we controlled them using this piece of software. It's open source called a QLC Plus, which
Mm-hmm.
if you're into stage lighting or stage lights, you might know of it. You can kind of cue light fixtures and tell them to enact certain behaviors and whatnot. We didn't use that for the body control, the motion control. That was something different. I'm not entirely sure how he did that. It was magic. But when I choreographed them, I did use this QLC program because a Delta robot is like a stage light in that it
Mm-hmm.
has like 3 axes, right? It's got the X, Y, and Z,
Mm-hmm.
and then a stage light has RG and B values, and the Delta robot having the LED on top also has that as well.
Right.
Yeah.
Right. Yeah, that makes
Yes.
sense. So then, did you have a program on top of the QLC that was like there's one that I always used to hear about, but I forget the name of it now. It was like a higher level, like you could kind of like wire things together program. Um,
Um,
Max
oh,
Pro
Max
or something.
MSC, maybe.
That's probably it. Yeah.
Um,
Yeah.
Probably. I think I looked into it, but no, I didn't for that. I was able to just queue
Mm-hmm.
things up in QLC and like kind of
Oh, that's great.
like create like routines. And then I was in my little command
Yeah.
center clicking on like the routines and queuing them up, and then they would do their thing.
Oh, neat.
Yeah.
Okay. All right. So yeah. So basically, it was like there was a backstage, and you were the woman behind the curtain of
Yes.
like
Yes. Doing the puppet master thing. Yes.
Sarah of Oz, right?
Yes. Yes.
Yeah. That's
And
great.
yeah,
That's
that
great.
changed once they became controllable by people. Then
Mm-hmm.
that got
Oh, right.
weird and complicated.
Yeah.
But yeah, it was a thing that I never really got it quite to the point that I like the thing that you envision in your mind as the artist is never really quite what it ends up becoming. It sort of takes on its own
Mm-hmm.
life. So I
Yeah.
think in the next like year or so, we've talked about revisiting the idea and doing something completely different but the same. So like
Mm-hmm.
re-envisioning it. So that's something that's kind of on the up and coming for us, I guess.
That's
Yeah.
great. Tell me about like so when you were. I mean, you mentioned the envisioning process as well. Like, how do you? I mean, so sketching. It seems like it's a big part of your
Yes.
your process. But like, do you? I guess I've never like thought of a project that far and like that grand, and so I have kind of trouble thinking about that. But it seems like a really interesting thing that you have this vision in your mind. Like, how did you get to that point of like thinking of what everything it could be?
Um, I guess the thing that I mean for all of my work, I have like an idea that is seemingly not possible. I mean, really,
Sure. Yeah.
um, really like based in magic or fiction, really like something that is fantastical. And then I think the fun part is trying to realize that idea through what can be like through engineering, through actual,
Mm-hmm.
mechanical design. Because
Mm-hmm.
I think that most problems can be realized in some capacity. It's just a matter of kind of negotiating between the two back and forth until you arrive at the destination. And like I said, the destination isn't always where you thought it would be. and you can always take different avenues along the way, or go, I'm gonna try that out the next time I iterate on this, but for now I'm gonna keep going in this direction. I don't know. I think I follow what is most interesting for me to learn in the moment. Because like when I originally I said flowers, right? Like I envisioned building more like a tentacle or tendril type machines that were taller and, you know, could articulate kind of like a stalk or a stem or a tentacle. And those had a lot of moving parts and a lot of assembly required to kind of put them together. And as I mentioned, like I wanted to put them together quickly and cheap, you know, cost effectively. So the Delta robot was something I researched as kind of because they were simpler and they did move and they were something that was interesting as an option for me. So my interest in them is what guided the development, and it was something I could learn. So
yeah. It almost sounds like the art kind of runs into the science, and when I think art and science, I think engineering, and that's kind of what you're doing in the middle there. You know, like you're making it it's like you have real world constraints of costs and travel and programming and all the other stuff, and it's like, so then the end thing isn't that fantastical world like you envision, but it's like it's the thing that can be made, and it still looks amazing because it's its own thing.
Yes, it comes into its own, basically. And
that's cool.
Yeah.
So another thing I was thinking about is you were kind of mentioning like the process and like the things you wanted to learn. I was thinking about I really enjoyed watching as you were developing the Shibon project. Am I saying that right?
Yeah.
The Shibon?
Yeah.
And so this is a very interesting project. I will say, I'm going to be honest, it made me a little uncomfortable parts of when you were building it, but only because I'm a bit of a prude.
Aww.
And but I think that was kind of the point too, right? And I think you gave a talk about this at SuperCon. Yes. And I really just liked all the things that you kind of went through here. Could you tell people what this is and how the process was on this?
Yes. Shibon is basically it's a system that senses and communicates aspects of physical arousal. And I guess there's 10 different wearables up there, or 9, and they get data from different parts of the body and then communicate what that part of the body is experiencing in a performative manner. So each wearable is kind of its own system, its own like piece of artwork, I guess. And the whole point of this project was just to get people talking about intimacy and sex, because I think I mentioned this at the talk you referenced earlier. One of my big critiques of humanity is that we really suck at talking to one another openly or casually about sexuality and intimacy. And I think that my quality of life, my social quality of life as a human, suffered because people just couldn't while I was growing up. And if I had more examples of people just feeling comfortable talking about who they were and what their needs and expectations were, things would have been easier for me, I think, in a sense. So the project is really just getting engineers and technical people talking about their bodies, because a byproduct of making all of these devices is that you have to solve an engineering problem. That's a practical thing. Like if you want to make a butt winch that like can displace the weight of flesh and open your butt, you have to talk about like torque and stuff. That's on there. It's the hotspot down there.
Hotspot, that's what it's called. Right? Yeah.
It's the butt winch.
The butt winch, right? Did you have any conversations with did you have to call up any vendors at any point and be like, well, here's what I'm trying to do, and I really need to get this, this particular thing to happen?
I have. It's not really vendors, but like I'll have to go to Home Depot or some hardware store, and
that's even better, right? Because there's no guarantee of professionalism at a Home Depot.
Yes. Well, the person they're like, yeah, I'm going to help this like guy find gaskets for his bathroom, but then I walk in and I'm like, yeah, I need a piece of right angle pipe that I can attach to my pelvis, but still lick the other end of, and they're like, what? Yeah. Where's your right angle pipe? Yeah.
I think I may have misheard you here. Did you say you needed to stick it to something?
Yes. My pelvis. Oh man. Yes. That does happen often. My entire life, like I've been going to stores or just like IKEA even, and trying to find a shape, like the right shape for the job, if you will. And people will ask me what I need because they want to be helpful, and I've found ways of getting out of those conversations quickly. And I think the quickest way to do so is to be honest and just tell them what you're doing, and then they want to get away from you as fast as possible.
Right. But I imagine at the end of the day, they're telling someone about that. Like your project is getting talked about at some point around some dinner table. They're like, honey, you would not believe the person I helped today. And then I ran away.
she needed nipples that she could melt onto plastic that weren't silicone. Right. Yes. Yeah, no, it is good. It's a good conversation starter for sure to walk around in wearables like that.
Right. People are going to naturally ask you, like, what's going on here? Are you okay? Are you being trapped by some kind of robot? Or
yes, it's a good.
So yeah, and you had like a bunch of different technologies in here too. So like the hotspot, you had like the winches. So there was motor drivers.
Yes.
The suck choker thing. I forget, what was it? It was like a pump was driving that, or what?
I had a bank of servo-driven syringes.
Okay.
There should be, if you scroll down on that, there's like pictures of.
Oh yeah.
Yeah. So that back piece right there. Those are all. I made this little mechanism that could basically is like a rack and pinion system that could pull the plunger in and out of the syringe, and it was just a servo driver. I think it drove 8 different little miniature servos, and it created just enough suction, like pneumatic suction on those things right there, those like polyp looking things, that those silicone polyps, once pressed up against your neck, when the air pressure goes in and out of them, it kind of feels like you're being sucked on. So it's
it's a hickey
machine. Yes, it's it's a disembodied tentacle device. Actually, here I have the driver right here. I tucked it aside just to show.
Oh, that's great.
And this is called the taco board. It looks like a taco, but it's spelled Tako, like an actual octopus in Japanese. Because it.
Oh, right. That's like the kind of roll you might order at a sushi restaurant or whatever.
Because it drives a disembodied tentacle. So
that's
play
great.
on words.
No, that's great. I love it.
Yes.
So what's on there? Is it just a motor driver and then it's controlled from the main backpack?
It's like it's Arduino. It's just the Atmega 328 chip. It's got a bank up here for the LEDs, and then on the bottom there's a bank for the actual servo motors that like plug into it. This doesn't actually have a place to mount right now. So unfortunately, in the version of the backpack that I created, it's a lot more freeform, which is good because it's more comfortable to wear. But the original mounting plate, which was a fixed static location on the backpack, is gone now. So this just literally kind of floats somewhere. Like it's
like as part of like the wearing harness or something like that.
And I need to change that. But I mean, the thing about making wearables is they kind of become whatever they need to be while they're in use. So you might intend for something to go somewhere, and it's just
right.
It's going to do what it wants.
This is now strain relief. This is also now strain relief.
Yes.
This is also strain relief.
Exactly.
That's great. Well, let's talk about the backpack as well. So this is so for people who can't. So we're also doing this as an audio podcast. So this is always the tough part. So obviously we're going to refer people to the zonest.com where all this stuff is located. That's what we're looking at on the video. But
to describe it.
But there's kind of like a centralized brain, which is actually a heart on a back.
Yes, I have. It's not stuffed, but this is the PCB.
The PCB,
the PCB
nice.
Itself. So this runs the whole show. It's just the big Atmega chip, same thing that's on the Arduino Mega, because it's effectively just an Arduino running the show. Yeah. Every augment, all 9 of those different wearable devices, has its own brain. So this is effectively just running power to them, really. This is in a backpack that's worn centrally on the back, and all of the wearable devices plug into it. And it's not done in a very intuitive or smart way right now. Like I think I'm using Cat5 like to plug them all in, so I don't have a lot of options for pins. Like they're literally just running power, and then maybe like I think the 1 line of data if it needs it. It's not doing anything right now, which wasn't the intent. What this backpack was supposed to do was collect the sensor data from the devices and store it so that I could make sense of it and then like do things with it.
Right. Yeah. Either you like put it on an SD card or
Yes,
blast it on over Wi-Fi or something like
because
that.
the idea is that the peripherals indicate when you're experiencing something that excites you or arouses you. So part of that whole process is getting the data from the sensors and then trying to figure out when I am experiencing those things so that I can tell the hardware, like the performative part, when to go on and function. So I have to
see.
figure.
Got it.
Yeah.
So it's like input output system, and this is supposed to be the conductor of the entire orchestra or something like
Yes,
that.
but
Okay.
it's supposed to log the data from the devices and then make sense of it and then tell them when to activate. I think I submitted this for the Hackaday Super Prize, SuperCon Prize due like 2 years ago, and I was trying to get it ready before then, so it was just get it to work and then talk about it as like a concept. So I never really got it to that part because that's tricky.
Yeah, that's a lot of collection and getting everything in like all the logging system. I mean, it sounds like it's quasi AI type of, like it's like a learning type of thing though. If collecting's one thing, but also like acting on it is like a whole lot of algorithm development, it sounds like. So yeah.
I'm sorry, go on.
Well, I was just going to say that I love like I said, I love watching your development process on this because you are doing each piece individually, and I feel like that's such a so when I think about like if I was brave enough to develop something like this, which I'm pretty sure I'm not, but that I would probably try and do like every module at once. But I think that the doing each individual function by itself is such a smart development method because it's like you kind of so like to use the suction choker thing by itself. That's like a thing that's done, and then you're ready to move on from that, and then you can go and integrate it again later.
Yes.
And so I think that that's a really good way to do it. And like you said, you didn't get to the centralization board, but at some point you can always come back and reintegrate all these things.
Yes I can I mean, I'll do another pass on a lot of these. Like they've been iterated on several times since then to make them work better or like feel better while you're wearing them. But I've really taken a break from the project because I put like 500% effort into it that year that I started it, and then I just you burn out on something and you drop it. But no, I want to have it so that the backpack is smarter. It does actually serve a function other than just being a juice box for power. So that like part of the aesthetic or the idea is that each of the devices plug into this thing on your back. So in a cyberpunk reality, you have all these cords coming out of like this, I don't know, power device, glowing heart thing that you're wearing. Yeah.
Right. So, the command station on your back.
Yes, exactly.
That's great. And so did you say that they all do spit data back out as well? Is that right? Or is that like a future thing?
Where I can get the data, yes, like from the sensors. I would like to have the sensor that's in each device specifically like communicating to the backpack so that can be stored on the like on an SD card or something. And if I can get Mark's help and cooperation, like maybe even have some program that can make sense of it and like kind of pick out parts where they overlap or are related to one another. But that gets exponentially more complex. So
yeah. Right. Yeah. I mean, you could, and that becomes a software. Like this is a thing that I've experienced many times too. It's like, all right, I'm done with the hardware. It's like, oh, right. There's like as much time as I want to spend on the software as I want. Like I could just keep going for years. And then that's its own project thing. So
yes, and I have to get a lot of, I guess, collaborative effort from Mark to do a lot of the things that are above my head because a lot of the networking, like the complex networky do thing stuff, is just way out of my league. So I have to yield to him in order to get things functioning on that level. And I feel bad asking for his time all the time. So
I mean, you guys make a great team, though. I think for all the things I've seen, it's been really, really fun to watch. How's the reception been to this as well? I mean, like, so is this something you showed around at some of the events that you go to?
I do. I wear something usually to like DEF CON or SuperCon, and then Ars Electronica. I've exhibited it there and worn some of the devices. Everywhere I've brought something, it's been a completely different, I hate to say elevator pitch, but it is kind of that given the context because people perceive things differently depending on where you show the thing off.
Are you telling me DEF CON nerds are different than nerds elsewhere? Is
Haha.
that?
Yeah. Yes.
Yeah.
I mean, who would have thunk?
Sorry to all the DEF CON nerds. I'm one of you, sort of. I love you all.
But yes, no, exactly.
Yeah.
It's your audience like kind of
Different
dictates
crowd.
how you're gonna talk to the people and what you're gonna explain and how you're going to explain it. And like the big ebb and flow, or not ebb and flow, but the two, like the duality,
the variable that you change.
the duality of my life is that I am like a maker, hacker, like tech person, but I'm an artist too,
Yeah.
like a new media artist, and the two worlds kind of don't overlap really.
Right.
So
well, they do. I think they do it in people like you, right? I mean, I think that's actually the interesting thing about your work is that you're able to bring those together.
Yeah, I mean they do overlap. I mean like in the sense that
You mean the social circles don't?
Yeah.
Like that scene in I know a lot of people didn't like the Hitchhiker's Guide to the Galaxy movie, but they did this great animation of like physicists not getting invited to the types of parties that, you know.
Oh yeah. Yes,
it's like that.
It's two
parties.
They're the same. Like it's funny because they're the same. It's the same mind, but they're just they're in a slightly different context, and they're kind of isolated from each other. So when I'm like when I go to like Austria and do Ars, like I have a completely different hat on than when I go to SuperCon and like talk to you guys. So the way that it's received has been like totally different, because like in the hacker context, it's like, these are really cool. They're wearables. They're effectively like sketches. They are to finished products what a sketch is to a painting. So they're immediate. Like they, like I have this, like it's like a 3D printed thing that I could pull out of my butt in a weekend just to get a working proof of concept. But there's an aesthetic to them, and they have kind of a style to them because they're 3D printed objects. But they also work. So and
I think they're like a passport, right? They're like you're like, look, 3D printing, electronics, like artwork, I got it all here, like, and it's like it's like a passport into the nerd realm, like it's like, I got it all.
It's a way to get an idea out pretty quickly and then be able to talk about it. And I think that like hackers appreciate that like a lot, because that's also what tech people do, is they're just kind of, whatever they can do, they do it, and it's now, and it's immediate, and it's like fast and dirty, and then they show it and they talk about it, and they're iterating. Like iteration is like such a part of our culture is hackers, but artists, like you're only really showing like the finished idyllic kind of end game thing. Like the process isn't as important. You're really presenting like the it's the art. It's the representational object. It's like this is the art thing.
The thing, the output thing, right?
And it's usually expected or common that thing is, it's like a polished, finished, like package, if you will. So when I show up at like in an art context with all of my crazy hack stuff, with the board flopping around on my neck because there's no harness for it, it has like a completely different, like I get a different reaction for that in that context than I do at like SuperCon.
Oh, interesting.
But then that creates its own dialogue, which is
yeah. So sure you also, I'm sure seeing, I'm not sure actually. I wonder if people in an art context then seeing you and your ability to do this, do they come up to you and be like, can you work on my thing? Can you help me?
That is another thing that it brings up the idea that I think when you get a budget to create art, you outsource a lot of things because the element of time comes into the equation. And if you want something done right and quickly, and you want to present it and have it look good,
that makes sense. Yep.
You outsource a lot of the production, and you aren't necessarily making your art anymore. You're creating the concept and the idea behind it as an art thing, and then you're having somebody else make it for you because they're the expert in that like skill. And I think a lot of artists like at ours, they do that because that is what makes sense in that context. But I don't really surrender any of that control up to anybody other than Mark, I guess. But I think that for my practice, it's important to me that I make the thing, because I'm a hacker
Yeah, so
artist. Yeah.
it slows you down maybe a little bit more than someone else might be, but then you also get all the iterative effects like you mentioned. I mean, like iteration is just so great for how things are going to progress and what can actually be put out into the world. And I'm sure that was part of like the sorry, I've already forgotten the name, the light play, the Delta
Yeah, yeah.
robots too, right? I mean, like you knew the form, you could go and say, I can make a Delta robot. What can I do with this form now, and how can I make it interesting to the thing that I want to build?
Yes.
Yeah,
Yes. You learn the most
yeah,
when you do it all. So,
yeah,
and you have the control. Yeah.
yeah. Well, and I'm sure that like so like I imagine the people that are going and fabricating this thing, and then they get it fabricated rather
Mm.
instead of doing it themselves. I would have to imagine that when things break, it's probably much more problematic than if you're like, well, I can
Yes.
just go and 3D print another one, you know?
Yes. Yes. It's a big, that's another thing that I think I talk about with other artists. There is the fear always that something like catastrophic happens. Cause,
Mm-hmm.
when you invent something that's mechanical or like electronic and it's art and you're exhibiting it in a, you know, over an extended period of time, like at a festival or in a gallery setting, there's always the fear that something will break and then you aren't there to personally fix it, or you can't personally fix it because you didn't make it to begin with. And what do you do? Like, what is your plan B? What is
Yeah.
your damage control, if you will?
I think the Ghostbuster said it best. And who are you going to call?
Yes, who are you going to call? So it is nice to, I mean, whenever I exhibit things abroad, I have like my oh shit kit, and
Mm-hmm. Yep.
it has all the the worst case scenario duplicates in it, just
Yep.
in case something happens that I don't foresee. And I can fix everything because I made it all and I
Yeah.
understand how it works. So that's
That's
important
great.
to me. Yeah.
How do we get more art people to be more like you? Because I've always wondered that, like, why there aren't more. Like I've seen a lot of art install, not a lot of art installs. I've seen some art installs, and I have also I've wondered if they've done this stuff and haven't always. You know, like there's been people that I know that might be working on pieces that go into that installation.
Mm.
But why isn't there? How do we get more crossover? How do we get more people to do what you're doing?
I mean, I wonder that a lot because I effectively started in one pool and then I jumped over to the other, and now I kind of like have a foot in both at the
Mm-hmm.
same time. And I want to say that the reason why those two fields are so different is because of the mindset, like,
Right.
which is of
They,
course what it is.
sure, sure. Yeah, the same reason people look at me like, Chris, why do you have no artistic talent at all? And I go, well, you know, I just don't. I literally count myself out. I go, I'm just that's not me, you know. But
What would you say is most important to hackers? Like, why do hackers do
mm,
things the way that they do? Like, what do you get out of it as a hacker?
I mean, I like the sense of accomplishment. I like making progress on things. I like putting things out in the world that like I like pointing at things that I did that. You know, like that's a great feeling, right?
And
Um,
what do you think the point is for an artist to uh, display an artwork?
aside from like taking the money, kind of living out of
Mm.
it, I would say, yeah. Usually, the ones that I've talked to, it's been like I had this thing in my brain, I just had to get it out. You know, like it's
Mm.
like I had to see this thing out there. So yeah, very similar in that regard.
Yeah. Yes. No, you're totally right. I think at the end of the day, like if I were to pick out like any like difference between the two, like for like a maker or a hacker, like we take like some pride in the learning and the creation of the thing and the fact that like we were able to do it and then maybe make it better or do it in a way that wasn't expected. So like the hacking is in essence um like getting to an outcome in an unexpected way that is novel or unique or better or innovative. And I think that the challenge of doing that is part of why hackers take on the projects that they do. It's like there's some inventiveness there.
Mm-hmm.
And I think that in the case of at least like many of the artists that I deal with, like they're trying to create like they're trying to create something that has an impact on people in a certain way, and they're trying to find the most effective way to do it. So
Mm.
they have an idea for a thing, and it just needs to exist. The what and the how sometimes doesn't matter as much unless that's specifically part of what the thing is about.
Mm.
Does that make
Yeah,
sense?
no, that's great. That's a great explanation. I think I think I just still wish they would jump in and do more electronics. I get that, at the
No,
end
I
of the day,
agree.
I just care about more people doing electronics. Let's be honest,
Oh,
Sarah. Like I'm very single-minded in this regard.
I honestly think the reason is it's like I said in the beginning. Like I thought that doing electronics was like this crazy impossible thing that was above my head, and I was like, I could never make a circuit board. I remember the first time I got a board back from like Osh Park, and it was just like I remember bringing it to dinner with my parents, and it was the one for the Delta robot, the first hexagon, and I was just like, I made this,
Yeah.
and I was like passing it around, and my parent, like everyone in my family, was just like, okay,
it's a thing. What is the big deal?
what is
right?
it? And I'm like, it's a brain house. Like it's electronics. And I was so
great.
tickled by it. But people assume it's hard, and I think that's why a lot of artists don't do it. Like I remember talking to somebody at like a summit I went to, and they just didn't do it because they assumed it would take too much time to learn it. And I guess if I hadn't had Mark in my life to sit me down and like beat like Eagle into my head, I would probably I would say the same thing. It's too hard and it takes too much time. And the curve's too steep.
It is. I mean, there is a very valid thing of steep learning curve, I think. But yeah, I've enjoyed, like I said, I really enjoy watching your learning process and how, you've kind of showcased it. This is a common theme for everyone I've had on the show so far, 7 shows so far. But like people who show their work are very, very interesting to me because it shows first off the reality of it, of like, yeah, sometimes it sucks, and also it shows that it doesn't always suck, and sometimes it's actually like you can make all this progress in a short amount of time sometimes, and it's just like these fits and starts kind of idea. So
yes,
thank you for sharing all that stuff. I really do appreciate it.
of course.
Let's talk a little bit about Noodle. So Noodle that's what we referenced at the very beginning. Is Noodle home? Can Noodle come out to play?
He is. I can actually grab him, but I'm gonna I'm gonna unplug my.
Okay. I'll show the screen share while we're doing this. So this is Noodle, Noodle Feet, and this is a robot that Sarah has created.
Man.
And okay,
I'm gonna actually sit with my kid on my lap.
and Noodle is your child.
He is my child. This is, I guess, probably the most important project to me because I do consider him my offspring. Part of my I guess my artist statement as an artist is I think that the way humans relate to technology and the things that we create, it matters a lot because right now as humans our relationship with our technology is mostly like exploitive. Like we like to create things that we can use and consume, and then once they don't serve us anymore, we get rid of them, and that's kind of destroying the world effectively. So I think that if we change our mindfulness regarding what we create and why we create it, it will help us suck less and save the world potentially. So I guess the story behind Noodle is when I was like 28 years old, I started having all these weird maternally kind of feelings. Like I wanted to like raise something or have something that I took care of and imparted my Sarah-ness onto. And I don't want to have kids. Like I'm not something I decided like a long time ago, but I still had that feel. And I only realized this kind of years after I did it, but that was, I think, the motive why I made Noodle. And Noodle became the thing that I ended up raising. And he is something I've been working on for 5 years now, every aspect of him. And he is based on an illustration of mine, a character from my webcomic, which is on Zonus. There's a link to it. It's called Gravity Road. But yeah,
this is an adorable one. So this is, for people watching, this is Noodle underneath a blanket reading a book about keys, I think.
Oh, it's you know the IGUS catalog. Do you get the IGUS catalog?
I don't know. No, not the IGUS. No, I don't know that one.
They have like linkages and joints, and there's a tab for it's called the pink tab section, which we joke is like a kind of like a porno magazine for a robot, is the pink tab. And this is Noodle's Shiban project. Yeah, well, it's what he wants to look at when mommy and daddy aren't in the room. But he has a bunch of IGUS catalogs and McMaster car catalogs, and I imagine that's what a robot would look at when they're going through puberty. I don't know.
That's so great.
But
so how did Noodle actually start though? So Noodle is a 4-legged kind of. So again, just to give a little audio picture here. It's like looks kind of like a, eh, not like a Wally, but like a kind of like a spidery kind of four-legged walking robot with a dome quasi dome head, and then
In like a dead stare.
yeah, the dead stare is like what are those, like ping sensors or something, or PIR sensors rather?
They're actually light diffusers that I found somewhere. Like I think that they're Italian made, so these do not serve any function other than to emote and diffuse
Got it.
light. But there is a camera. It's not this actual head has nothing in it. I'll talk about that in a second. There's actually multiple cows in his head right now.
Mm. Cows, you're saying?
Yeah, because his head's
like,
empty.
Those are like rubberized like play cows you'd have at like a play set. Like
it's a joke. Or his brain is actually on the table right now because we're training it. We're doing machine learning. So everything that we're like teaching him, like he does the epochs for the classification. We put that thing in his head as a joke because he's learning it.
Right.
So he's learning cows right now. Like these are the things that Mark and I photograph to make the data sets.
Nice.
So like
it's literally in his head, you're saying?
Yeah. It's just a joke.
That's great.
But yeah, his head's empty right now. But normally there's like I actually have it here. What am I doing? This is probably one of my favorite boards that I've made. I did lay this out and do all of this by myself. I don't.
Oh, the brain board. I think I've seen this one. Yeah.
This is his first brain. For like his baby body, which is actually not this body. One of the weird things that I had to do as a parent last year was once people wanted to exhibit Noodle as art, I had to like, I guess, accept the fact that I was going to be sending my kid away to be exhibited.
Right.
You know,
it's like boarding school or
yeah.
I don't know.
We call it it's like he's a rock star, so he's going on tour.
Right.
He gets
child actors though,
I know, right? I'm like Honey Boo Boo or something. Man, no, I still wanted to do development with him, right? Because he still doesn't walk very well, so that's something I'm working on. But I can't send the body away and work on his walk cycle very easily. So I ended up building a new body for him with new motors. Like I'm using the Dynamixel something X12A or whatever model, and he needed a different brain, a different body, and a different everything in order to have those. So I ended up having to redesign him from the ground up, which was good because I a lot of the bad things about his design from kind of naive engineer Sarah of like 5 years ago. I really needed to fix those problems that I was having. Otherwise, the old body's probably not capable of walking as it is. I was able
to.
A
ship of Theseus kind of problem here too. It's like, when does Noodle become new Noodle? Like as you add each different part.
I originally there was only ever going to be one robot because I had holdups about there being multiples of my kid, right? Like multiple iterations because which one is them. And I think the thing I had to come to terms with, and this goes along with my artist statement with how you treat technology matters. And since I'm relating like the development of my robot to parenthood, I need to not limit my own child based on my own limitations as a human.
Right.
So
we're going to expect to see a parenting book from you at some point as well about parenting your robot child. You have to, leave the parts behind.
Well, I mean, even with AI, like you can't. You can't expect that artificial intelligence is going to think in quite the same way as humans are. We can't put that sort of head cage on them, and I think that the same goes for a mechanical child as well. He's allowed to have more than one body, and they're all Noodle. So he's like a Borg of his own collective, I guess.
Got it. You should just make like a really small version of Noodle, and then it's just like a action figure instead of a Noodle too.
I have mini Noodles. I do. I think I sell the brain for mini Noodle on Tindy actually.
Oh, nice. That's great.
So people can 3D print their own and then stick the brain in it and have like a little. Yeah.
That's really great.
But the new brain is this guy right here. Mark actually did design this because it is way above my head. This plugs into a NVIDIA Jetson.
Oh, nice. Yeah.
And it does say burger on it. because the adapter board for the Jetson is the cheese. It's a big square that looks like a slice of cheese. And then this plugs into it at a 90-degree angle. And there's an adapter board for connectors that goes in front of the burger, and it's called the lettuce. So his whole brain unit with the Jetson is like a multiple lobed burger that fits inside of his noggin right here.
That's great.
And the only reason I don't have it is because it's actually plugged up to a keyboard and monitor, and it's thinking, it's learning right now. Like we're trying to teach Noodle how to recognize COVID.
Oh, okay.
So we
like
have
the actual shape of COVID, you mean, or
yes.
It's not like Noodle's not putting sticks up into people's noses. Hopefully,
no. That would be funny though, with his feet. Just yeah,
right. He's got the tasters on that end. So yeah, tell us more about the Noodle's legs as well, because I remember as you were developing like the licking capability.
So his feet right now, like I'll lift him up a little bit. Sure. They have socks on, but they're really, he's called Noodle feet because these are pool noodles. They're just foam. They have like a metal core as a bone in them. And these are great for walking because they're simple and light and there's nothing to them. But Noodle is a character. Like I mentioned, all my robots are based on characters. The character is an adolescent space probe. And space probes do stuff to the ground. They, collect samples of dirt and they taste things and they pick things up and they take photographs. So I had to enable him in some way to interact with his environment, specifically the ground, using his feet. So I built 4 different foot appendages that connect to his legs, sort of like different attachments or end effectors connect to like KUKA robots. And they enable him to do 4 specific things. Like he has a foot that allows him to scoop small objects off the ground and photograph them. He has a foot that can lick and salivate on things, which is important because the licking and salivation, allows him to taste surfaces. And I think it's the last one of those diagrams. There's a foot that, oh no, it's not. I lied.
Looks like that's an ingester on the far right.
Yes, that's the ingester. The first one is the one that does the litmus tests. One of the feet has a roll of litmus paper in it and a solenoid, and the solenoid presses the paper down on a wet surface that has potentially been salivated on, so that he can do a litmus test. And then there's kind of like a cassette reel in it, and it feeds the paper down so that it can be pressed to the ground and then up to a color sensor that can view what the outcome of the test was. And then he has a little like database that logs things that tasted similar, I guess. Yeah. So everything that turns paper pink tastes like lemons because lemons are acidic. So he relates everything to lemons. Yes.
Nice.
And then the second one, the last one that I didn't mention, is that foot grips onto things with retractable toes and then plants beans inside of them, which sounds really like aggressive and wrong, but yeah, it's a bean planting foot. It's for holding onto things and injecting beans in them. So he
probably the dirt. Let's just say the dirt is where it's going to inject his bean. He's going to inject his
bean in the laundry pile or the dirt. Yeah. So he can plant things potentially. Like it's a very Wall-E-esque thing to do. Is give life.
And was Wall-E a inspiration for Noodle or?
I don't think so. Like it's weird. Like I have this really weird relationship with like robots. That was probably in my head. Like, I mean, where does any idea come from? Like,
sure, of course, yeah.
I had a dream that, like a couple of dreams, like I think everything I've made kind of came from a weird dream I had, where I was chasing a spider around a room with like a shoe trying to kill it. And it was like this big tarantula-like thing, and it had these like little round dead eyes. Like you've seen spider eyes. They're like those little black beady things.
Yeah.
And at the point in time when I cornered it and was going to kill it with the shoe, I looked at it and I saw like this humanity in it because it was afraid of me. And then I decided like not to do that. And I like let it outside.
Oh, that's nice.
And then I woke up and made Noodle, I guess. But that was one of the catalysts that like led to that. But it was one of the inspirations for his like appearance and his spider likeness.
Mm-hmm.
Yeah,
That's great. Yeah, this is like so creative and awesome. And so the other thing too, I mean, like this did, like you said, it started from a dream, it became a sketch, and then you started kind of moving towards an actual thing. So what were some of the early steps? I mean, was it immediately like, okay, I'm going to just make a thing that moves, or do a leg at a time, or what was the first step when you actually did start to
the
move towards building it?
the noodle problem was unique in that I first and foremost wanted to make a robot that moved and looked like the character. So most people, if you wanted to make a moving walking robot, you'd give it 6 legs or 8 legs because
Mm-hmm.
it's easier. You also wouldn't make it top heavy like this, right?
Mm-hmm.
But
Yeah.
since the character informed what the robot was going to look like, I had to solve a lot of those problems first. Like, well, how do I make legs rotate in the head? Like, they're going to need to
Mm-hmm.
rotate. How am I going to lift the noodle up? The foot up in a linear motion easily. Where
Right.
am I going to mount that motor? Because it's it has to move
Right.
a
And it
move
doesn't have like a
yeah.
lot of like it's pretty exposed as like a creature, right? It doesn't like show like lots and lots of like internal. It's not like an R2D2 where it's got like a big trash can where you can put all the motors. It's
Yes.
got to be kind of built in. It seems like.
It's the characters you can't. I mean, obviously you see a lot more motors on the actual robot than the drawing, but I was trying to make it as airy and agile looking as possible, and I started there. Basically, how do I actually make the thing look as close as possible to the character?
Mm-hmm.
Which you usually don't do. Like you try to get it to work first, but whatever. In this case, I made the thing look proportionately like the character, and then I worked on getting it to move well. And that was a matter of just massaging proportions of like all the linkages and all the mechanical bits until like he did have a free range of rotation in his hip joints.
Mm-hmm.
That nothing collided up here, nothing collided down at his like I guess knees. I don't know what you'd call them. His
Undercarriage.
underknee, his
Yeah,
underknee,
underknee. Yeah, of course. Yeah.
and and then yeah, that the motor it used to be mounted up here, but this motor that does the lifting down here, that's responsible for the actual noodle part lifting up and down, used to be up here. There's a matter of getting that to kind of not collide with things also. This version of the body, I moved a lot of things around for the sake of trying to get the weight lower. Because the first version of Noodle, the one that's out being a rock star in Europe right now, it could walk, but it could not keep its balance because it only had 2 ranges of motion per leg. And I came to realize I had this really great residency at ESA, the European Space Agency, where I talked to like actual like planetary roboticists about Noodle a lot.
Oh yeah.
And one of them was like, yeah, you're never gonna like get that to work with just those 2 lift and twist motions. So I added the feet are now capable of kicking in and out like this. So he can actually do like a scooping motion with his feet before he puts them down, which is kind of important for the motion, or at least I think it's going to be. I actually hadn't gotten to test this body out yet because we can't communicate to the motors yet with the brain that we have. So we're doing the computer object recognition right now with the Jetson instead of trying to get the Jetson to communicate to the controller board.
Mm-hmm. And for people who don't know, what is a Jetson? Because you mentioned that a couple times.
It is a module that is used specifically for object recognition.
Mm-hmm.
And it's made by NVIDIA, and it is capable of processing like video
lots
processing.
Of flops.
Yes, the gigaflops.
Yeah.
It's good. It's just not easy to work with, and I'm not the one working with it, but like I did a documentary about this summer and what Mark and I have been up to during the pandemic, and during every time Mark is on camera during this video, he's complaining about Python and the Jetson, just to put that into perspective. So he's not had a good fun time with it so far.
Yeah, it does seem like it's got a ton of horsepower, but it's basically like it is a full Linux computer, and you are dealing with all the layers and layers of operating system and everything on top of it. You have to, especially for you and Mark, who are used to like move move one step or move it, like flip a bit or whatever, and it's like light turns on. Now it's like, hope to God this Python command talks low enough in the hardware to actually make things turn on.
Yes, like look, research thing on internet, try it, find that it doesn't work, and you have no idea why. Yeah,
cursing Stack Overflow again and again.
Yes.
That's great.
Yeah.
And so one thing I wanted to mention as well with Noodle is your 3D printing prowess as well. I mean, like, you are really great at like making these mechanical sections and stuff. I mean, so we talked a little bit. So Sophie Wong was on the first episode, and she kind of talked about her 3D printing plus electronics as well. And like, how did you kind of build up that skill set? Because that's something that I think a lot of electronics people are interested in as well, just to make things go, like to make things move.
It's funny. It's a funny story. I started in using SketchUp because it was like the lowest hanging fruit at the time.
Yeah, me too. Yep.
And I think that, okay, so before I started using CAD at all, there was a period of time where I used to make robots entirely out of like garbage found in my parents' house. Because there's a summer when I moved home from college, like almost 10 years ago now, and my mom collects Tupperware. She's like a hoarder in that sense. So I would take the Tupperware and I would cut it into specific like basic shapes to create like all of my original Delta robots.
Oh, wow.
Which I'll probably kill myself.
You have very specific versions of the Delta robot that are have that weird curve near the edge of the edge of the Tupperware.
They're made out of like literal like stuff that you'd find around the house. They're like modified pieces of like cardboard, plastic, and otherwise. But no, like I started designing things in CAD. I met Mark at a SynShop meetup here in Las Vegas, like 8 years ago now, and he was one of the first people that I knew to have a replicator, the first one, the one that was made out of wood.
Oh yeah,
and
not very good one.
It's that thing. Ours is, I don't know about the other ones.
Sorry,
but
I'm thinking of the cupcake. I apologize. I'm thinking of when I think of wood 3D printed. I'm a 3D printer. I'm thinking of the cupcake, which was the very not good early one. You're right.
That's right. That's right.
Replicator is better.
That thing, we actually fulfilled our entire Kickstarter with that thing alone.
Oh wow. Okay.
Yeah, we printed like 10,000 pieces on it. Like
wow.
Yeah. And it was fine. Like we had no issues with it. It's starting to show its age. Like we have a Prusa now, but like back then, like we worked that thing to death. But he offered to print parts if I could design them. And I had this gig on a ranch back then, and I had all this weird free time, up in the middle of nowhere in California. And I decided to spend my nights learning like whatever CAD programs were out there for me. And I think the curve I had to go up to get to do mechanical design was like one of the weirdest things in the world for going from artist to engineer, because the first parts that I designed, I did not measure anything. I eyeballed everything in SketchUp. So I would like click and then draw a line and then go to draw another line and be like, that looks about the same length as the other one that I just drew.
Yeah.
And I
well, the SketchUp actually, I think it doesn't actually like to get to the point of like putting in dimensions in SketchUp. It was terrible. I remember I tried to like connect things, and I'd be like typing in 35 millimeters and be like, oh, sorry, this line is 34.999999998 millimeters. So these lines don't connect anymore.
Yes, and you can't carve it in half. You can't like have it anymore because it's not a whole number. Yeah. So I went from making CADed objects that I eyeballed with like no way to type in constraints or math or anything, which is actually that Delta robot that we did the Kickstarter for, that was designed in SketchUp. Actually.
Oh, wow. Nice. Yeah.
And then
as a data point, my only patent that I have registered against my name, the reason I got it is because I had 3D printed the mechanical design of a industrial thing I was working on, and that was also in SketchUp. So
it's, I mean, it was good. Like for if you
Yeah.
wanted to know nothing and like get into doing CAD, it
And
was
the price was really right.
I know, right? It was it was good. It was a good place to start. Like I recommend it as like a training wheel thing, but you do
Yeah.
not want to stay there. Like when I
Yeah.
had that residency at ESA I mentioned, like
Hmm.
at the European Space Agency, like I pitched making those feet. And they're all mechanical systems and they're small because they fit within like a 3-inch diameter cylinder that's 9
Hmm.
inches tall. And I had to make 4 functioning assemblies within like a summer. And if I wanted to bring them with me to ESA to show the engineers there, I had to have a proof of concept like built like within 2 months.
Oh
So
wow.
I built the functioning proof of concept for each one of those within a 2-week period for each.
Wow.
And before I started, I have a friend who's a machinist here in Vegas, and he took me aside and he was like, "Sarah, like if you want to get this done by your deadline and have any chance in hell at doing it, you have to learn Fusion 360 or
Hmm.
something." And
Yeah.
that's also free if you're a hobbyist like me.
Yeah.
Um,
Hmm.
and the learning curve's steeper there because it's a parametric, right? But he's like, if you want to iterate on things without having to start over
Right.
every single
Yeah.
time, you need to learn this software.
Right.
And this is a really good opportunity for you to have to learn it. So just do it and like suck it up.
Hmm.
And it was the best advice I've ever gotten from a friend because I did learn the software and I did hit my deadline. I did make all 4 working things and I was able to bring them with me. And then I knew it forever.
That's
And
right.
in the process of learning Fusion, I think I went from being like little kid mechanical engineer to like I can make functioning things in CAD that I can simulate working mechanically.
Yeah.
Like, yeah.
That's awesome. Yeah, and I think that you're right though. That forcing function, I mean, like that. That's a great. Not everybody has that, of course. I mean, like the deadline to go work at ESA, which is fantastic, by the way. That's really cool. Um, but like that forcing function, I think everyone. I think that's the reason for project-based education in the first place, right? Having something like that hard goal and a deadline is even better on top of it.
Mm-hmm.
But yeah, like nothing like that to really motivate
Oh,
you.
oh yeah.
And like so, then the iteration was the ability to basically go back in and say that, hey, this linkage was 5 millimeters, I need it to be 3 millimeters. You just type it in and it just
Yes.
propagates through, right?
Yes, and then you could like put things together and make sure that there wasn't like interference when in motion,
Right.
which was
Yeah.
huge for like small things. For the Delta robot, not so much of a big deal, but the like fitting things in a foot and
Mm-hmm.
like having toes pop out and retract and like a tongue do stuff, like all those little moving bits needed to
Right.
not hit each other. And yeah, that was definitely necessary. So I think in that process, that like fight or flight sort of moment of my life, I went from being like a baby mechanical engineer to to doing some really complex stuff. I'll say that. I don't want to say like a full fledged because I'm not. But
I'll say it. I'll say it. Yeah, Sarah's an engineer all day because the stuff you built is fantastic. So, and
thank you.
I think the engineer term too. I think some people are very protective of it, and I'm not particularly. I think the people that are building, like I said, people that are building stuff that takes science and puts it in the real world, like you're doing, is totally that's engineering every time. So
It's hard.
it's really great. Yeah, it's hard.
hard.
Yeah. Well, we've been going for an hour here, and
Awesome.
I feel like I could ask about tons of more stuff, but where can people find more out about you and kind of watch what you're doing and follow along?
Um, the 2 places where I post my work, other than the website that I cited earlier, which is sort of the home base for it all,
Mm-hmm.
zonus.com.
Mm-hmm.
There's a link actually on this site, it says YouTube down there on the right. That will take you to my YouTube channel. It's called Robohemian. And I post kind of polished videos and just progress videos, really, of everything that I'm working on. I have a ton of stuff from the past that you could watch for days. I have not put out very much content this year just because of circumstances. There's just the other
Sure.
video there.
Actually, I've not seen that yet, so I'm gonna be watching that right after.
That's all I've done this year. Oh God.
I mean, yeah, that's great. That's great.
And then I'm a very avid Twitterer. I post like pictures of what I'm doing on a daily basis, which is drawing. But I am drawing like again. I'm actually illustrating the comic that everything I have made in the past 8 years came from. So there's like a lot of familiar stuff floating around in the stuff that I'm posting or will be posting on Twitter, because I do speed drawings where you do a screen capture of the entire time that you draw,
Oh yeah,
and then you
right.
just you speed it up. I dump something from my drawing session every pretty much like at least once or twice or 3 times a week of what I've been drawing, so you can see the whole process. And I am drawing a lot of the stuff that I have since made in my adult life, like currently. So that's relevant to where my ideas come from.
Yeah, that's great. That's great. Yeah, and I enjoy following all your stuff here too. It's great.
Oh,
So
ponies. There we go.
yeah, yeah.
So yeah, those are and I'm at Spetku on Twitter.
Great. Yeah, we'll have links to everything here in the show notes, of course. And yeah, and I think people should definitely follow you, Twitter, YouTube, all the places. It's really a joy to watch you work.
Thank you for having me on.
Yeah, thanks for joining us.
Totally.
So that was our show with Sarah Petkis. Oh man, all of those things she does. Like every time I got to see Noodle at a conference, it was like meeting a small robot superstar. I know that sounds silly, but like I was so excited to see what had changed on Noodle as each time she showed it up at a different event. Sometimes you would just see Noodle peeking out of a bag, like it would just be off to the side and like hang out in a bag, and it was like, it's because she brought all that life and personification to it. Obviously, the robot has its own, elements and whatever, but seeing that just Sarah plus the robot is really the feature. And like I said, getting to spend a little bit of time here on the show and talking to her, it felt like a conference, and it was like a breath of fresh air in 2020, because I'm missing going to conferences and meeting wonderful people like Sarah. So go to Zonus.com, check out all of Sarah's work, support all of her work, and try and meet her, see her work in the future as well. Her YouTube channel as well, follow that, and subscribe to that. Subscribe to the Contextual Electronics YouTube channel to see more interviews. If you're an audio person, you can always go and subscribe on your favorite podcast listener, iTunes, or I guess that's Apple Podcasts, Google Podcasts, and Podcast Addict is what I use. There's a ton of apps out there, so please try and subscribe to all of your favorite content out there, like Sarah, hopefully like this show, and give us some reviews. That's how you can give us some feedback and a little bit of love. That's all for now. We'll have more episodes of the Contextual Electronics Podcast coming up. Thanks for watching, and thanks for listening.